شاء الله.
Test. Ladies and gentlemen, Bismillah ar-Rahman ar-Rahim, distinguished guests, esteemed speakers, and respected colleagues, Assalamu alaikum wa rahmatullahi wa barakatuh. It's an honor to stand before you today as your host, Zainab Taruti, a student of nuclear power engineering from King Fahd University of Petroleum and Minerals. Today, we gather as scientists, engineers, visionaries, and policymakers, united by a shared goal to shape the future of nuclear science and technology under the inspiring theme, Lead the Innovation.
Ladies and gentlemen, it's my privilege to stand before you today as your host, Muhammad Al-Ibrahim, a nuclear power engineering student at King Fahd University of Petroleum and Minerals. Please join us in welcoming the Director of Interdisciplinary Research Center for Industrial Nuclear Energy. It is with a great honor that I introduce to you Dr. Afaq Shams to give us a remarkable highlight about SCOPE-2.
Ladies and gentlemen, distinguished guests, greetings and salutations. May the peace be upon you. On behalf of my conference co-chair, Dr. Khalid Al-Adal, and I, it is my honor and privilege to welcome each and every one of you at the second edition of Saudi International Conference on Nuclear Power Engineering. The theme of the conference is Lead the Innovation. It reflects KFUPM's commitment to foster innovation, research excellence, to promote excellence towards a better future for everyone. Under the umbrella of this theme, this conference provides a platform to inspire innovative ideas and also foster collaboration. The conference timeline, we started 1st of March when we announced the call for the papers, and afterwards we went through several processes, submissions, reviewing, until we informed the acceptance to the contributors. And we were overwhelmed by the enthusiasm and the response we have received. We have received 350 submissions from more than 50 countries, representing 100+ institutions. Our technical program committee consists of 11 members representing 9 countries, and scientific committee who helped us reviewing all the submissions, more than 55 members from 30+ countries. Here are some key highlights of the conference. We have received 600+ registrations, 200+ technical presentations, which will cater 9 different tracks covering the wide spectrum of nuclear energy. We are honored to have 5 keynote speeches, 7 invited talks, and 1 panel discussion reflecting the theme of the conference. We also have 40+ poster presentations, 70+ research pitch competition presentations. Yesterday, we hosted 8 engaging workshops covering different topics of nuclear energy. To award the excellence in research and innovation, we have 21 awards in 5 different categories, ranging from undergraduate student to the field experts in nuclear energy. This time, we also announced a student's travel grant. 27 students received the travel grant. Initially, we announced 20, but the response we received was overwhelming, and so we increased the number to 27. This is thanks to the vision, and generous support of our Vice President of Research and Innovation, Dr. Ali Al-Sheikhi. Thank you, Dr. Ali. We are also pleased to inform that this conference has 3 special issues: nuclear engineering and technology, nuclear engineering and design, and our very own Arabian Journal for Science and Engineering. So selected papers will be invited to submit for these special issues. Ladies and gentlemen, there is a thought: how would you lead the innovation if you do not set an example? So with great honor and privilege, I would like to show you our innovation as an example. Ladies and gentlemen, let me introduce you our SMR, Sama. Sama is a beautiful Arabic name. It means sky, or at KFUPM we call it dreaming big. It is a collaboration between 2 institutes, KFUPM and Paul Schroeder Institute. It is a perfect example how you work together from sketch. This is the first sketch of our SMR design we made on the 17th of October 2024. In a short amount of time, you can see this beautiful design. Wish you a fruitful conference. I have a personal story to share with the permission of Dr. Ali. March 2022, I joined KFUPM. This is right after the COVID. I packed my bags, left my home in the Netherlands, and I moved to Saudi Arabia. Since that time, my friends, colleagues, collaborators from around the world have been asking me, how is it to work at KFUPM? How is it like to live in Saudi Arabia? My answer is very simple. If you have a dream, and if you have the zeal and the vigor to accomplish that dream, if you can't do it in Saudi Arabia, you won't be able to do it anywhere else in the world. Ladies and gentlemen, I wish you a fruitful conference. Thank you very much.
Thank you, Dr. Afaq Shams, for this inspiring words. And now I would like to invite Dr. Sharaf al-Sharif, the head of the atomic energy sector from King Abdullah City for Atomic and Renewable Energy.
Assalamu alaikum wa rahmatullah. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, distinguished guests, it is a pleasure to join you at the second SCOPE conference here at KFUPM after the resounding success of the first edition a couple of years ago. I'm honored to speak on behalf of the CEO of King Abdullah City for Atomic and Renewable Energy, an institution positioned at the heart of the kingdom's clean energy strategy and long-term technological vision. This conference is more than a technical gathering. It is a place where vision meets capability, where young talent stands beside global expertise, and where the kingdom's industrial ambition connects with the world's most advanced knowledge. SCOPE brings together every part of the Saudi nuclear ecosystem: academia, research centers, government entities, operators, regulators, innovators, and most importantly, the students who will lead what comes next. We also welcome our international partners whose experience elevates the value of this event. In this room, we see the full chain of progress: ideas, facilities, talent, industry, and commitment. Nuclear energy in the kingdom is not a project of a single institution. It is a national effort built through shared learning, open collaboration, and a unified commitment to safe, clean, and globally competitive technology. At KA Care, we see nuclear energy not only as a source of electricity, but as a catalyst for national prosperity, scientific advancement, and industrial diversification. Our mandate spans energy policy advisory, technology assessment and development, human capital growth, and the promotion of peaceful nuclear applications across multiple sectors. It is a mandate designed to meet today's needs while building the knowledge, supply chains, and industries of tomorrow. Over the past decade, the Kingdom's nuclear program has advanced in a deliberate and systematic manner, from the establishment of the Saudi National Atomic Energy Project to the creation of an independent regulator, to the launch of the Saudi Nuclear Energy Holding Company and UAE Nuclear Energy Company. The institutional foundations are now in place. The project to build the Kingdom's first large nuclear power plant is progressing. Site characterization and licensing activities have been completed, and bid invitation specifications covering thousands of technical requirements aligned with the highest international standards have been issued to leading global vendors. This project will provide the reliable baseload electricity, strengthen local industry, and secure long-term energy resilience. At the same time, we're preparing for the next frontier, small modular reactors, an example of which we've just heard. SMRs offer flexible, low-carbon energy solutions for electricity, desalination, hydrogen production, and industrial heat. They can decarbonize the sectors that define our economy: metals, petrochemicals, refining, and mining. Our work today is evaluating technology readiness, regulatory pathways, system integration, and economic competitiveness to ensure that when the Kingdom enters the SMR market, it does so with capability, supply chains, and human capital, not just imported hardware. A responsible nuclear program also demands responsible waste management. The Kingdom has adopted a national policy for radioactive waste, supported by clear regulatory frameworks and long-term planning. KKR is building the infrastructure and expertise to manage waste safely and transparently, in full alignment with international standards, protecting both people and the environment. But at the core of every nuclear program is not technology, it is people. Facilities can be constructed and equipment purchased, but knowledge must be cultivated. KKR has long invested in that knowledge, training engineers, supporting scholarships, and preparing regulators, operators, and researchers. In many ways, KKR has served as the nucleus of Saudi nuclear human capital development, from which capability continues to expand. Yet the next chapter belongs to the students and young professionals in this room. You are the future designers, operators, safety specialists, and innovators who will define the Kingdom's nuclear landscape. This program will outlive all of us. It is being built for generations and requires your ambition, your curiosity, and your leadership. Ladies and gentlemen, the story of nuclear energy in the Kingdom is still being written. Our progress is not accidental. It is the result of long-term vision, patient investment, institutional cooperation, and a national belief that Saudi Arabia can lead in advanced, clean, and peaceful nuclear technologies. KKR stands ready to continue working with partners in government, academia, industry, and the international community. Together, we are building not only energy security, but scientific depth, industrial capability, and new economic opportunity. And to the young people here today, you are not the future of the sector, you are already part of it. Your ideas matter now. Nuclear energy is more than power. It is innovation, resilience, economic strength, and national competitiveness. And with the will of Allah, the Kingdom's nuclear journey has only just begun. Thank you.
Thank you, Dr. Sharaf Sharif. And now we would like to present a short video about the Interdisciplinary Research Center for Industrial Nuclear Energy, which was inaugurated in SCOPE-1 by the President. The video highlights the initiatives that the center is undertaking.
KFUPM remains at the forefront of the Kingdom's economic ambitions, driving the country towards the new global digital economy through promoting research and education to improve the human condition and advance solutions for evolving challenges worldwide. The Interdisciplinary Research Center for Industrial Nuclear Energy is recognized for its dedication to fostering an environment that promotes cutting-edge research and innovation in nuclear science and technology. The center's primary goal is to strengthen the Saudi nuclear ecosystem, contributing to national progress while meeting global needs. The center envisions itself as a national leader and a global benchmark in interdisciplinary nuclear research, striving to drive innovative advancements in nuclear energy for industrial use. Its mission is to conduct world-class research and foster innovation in nuclear science and technology, supporting the growth of Saudi Arabia's nuclear sector across key industries through comprehensive outreach, education, and training programs.
At the forefront of nuclear technologies, the center emphasizes on developing advanced nuclear reactor technologies, with particular emphasis on Generation 4 reactor designs. These are innovative reactor design systems. They are highly efficient and can be used for a wide range of applications, for example, desalination, hydrogen production, and so forth. If I describe our Industrial Nuclear Energy Center in one sentence, then it is an incubator for technology development.
The center is focused on 4 primary areas of research. The first is in advanced reactor designs, the second in the fuel cycle and waste management, the third in radiation safety and environmental protection, and finally also in nuclear systems and safety.
The center is equipped with specialized laboratories such as the Radiation Protection and Safety Lab and the Nuclear Simulation Lab. Since Saudi Arabia is a newcomer to the nuclear industry, the center has established strong collaborations with experienced international partners to enhance its research and development efforts.
The center is also noted for organizing the inaugural Saudi International Conference on Nuclear Power Engineering, SCOPE, at King Fahd University of Petroleum and Minerals. This groundbreaking event, the first of its kind in the kingdom, marked a significant milestone in Saudi Arabia's commitment to advancing nuclear research and development for peaceful purposes.
SCOPE brought together distinguished researchers, scientists, professionals, and students from 39 countries, creating a vibrant platform for the exchange of ideas, sharing knowledge, and exploration of the latest innovation in nuclear engineering.
These interactions help me to gain a deeper understanding and also keep me updated on recent developments.
The center serves as a vital hub for developing human capacity in nuclear science and technology.
The center aims to become a leading institution for cutting-edge nuclear research and innovation, leveraging its extensive international network to support and enhance Saudi Arabia's nuclear ecosystem.
We welcome you all to come and join us in these incredible endeavors and be a part of history as we lead the innovation together.
Ladies and gentlemen, it's with great honor that I introduce to you our keynote speaker, Dr. Ki-Young Choi from Korea Atomic Energy Research Institute.
Good morning, distinguished guests, colleagues, and friends. It is my great honor to be here on behalf of CARI. First of all, please allow me to express my sincere apology that our CARI president, Dr. Han-Kyu-Ju, he couldn't be here due to other commitment. He asked me to convey his warm greetings and strong support for this conference. Ladies and gentlemen, I'm very pleased to join the second Saudi International Conference on Nuclear Power Engineering, SCOPE-2. My warm congratulations to the organizing committee of KFUPM and everyone who made this conference possible. SCOPE is a meaningful event. It brings together scientists, engineers, and policymakers to share knowledge and ideas about the future of nuclear power, not only in Saudi Arabia, but also across the world. By continuing this series, Saudi Arabia is showing real leadership in promoting open dialogue and technical exchange across the Arabian region. Today, as we all know, the global energy landscape is changing rapidly. We face rising electricity demand and the increasing concern of climate change, and also urgent need to reach carbon neutrality. In this respect, nuclear energy is once again receiving renewed attention as a reliable, clean, and always available power source. Nuclear energy can work together with renewables, providing stable energy mix. At the same time, small modular reactors are now key focus of global interest and competitions. They can be built faster, operated more flexibly, and deployed safely even in remote areas and the industrial site. For many countries, including Saudi Arabia and Korea, SMRs represent a practical pathway to achieve both energy security and decarbonization. KERI, as Korea's only national leading research institute for nuclear science and technology, is taking the lead in developing a customized research reactor and a wide range of SMR technologies, including light water design and also advanced Gen 4 systems. Among them, smart reactor is one of the one of the most mature and proven design. It achieved its first standard design approval 2012 and the second standard design approval in last year. It confirming its technical excellence and enhanced safety. I also like to highlight that KERI and Saudi Arabia has built a long-standing partnership through the Smart PPE project. Through this collaboration, two countries have shared not only technology, but also a vision for peaceful use of nuclear energy. We sincerely value this friendship and look forward to expanding it in the coming years. Regarding the research reactor, we have built a strong partnership with Jordan, helping them build 5 megawatt JRDR. We are currently exploring new opportunities to expand its applications, such as neutron transmutation doping and other advanced ones. Furthermore, most recently, KERI signed a contract with the University of Missouri in US to supply next-generation research reactor design. These achievements indicate that KERI is taking a leading role in developing advanced research reactor systems. Looking ahead, KERI will continue to work closely with international partners to promote nuclear energy as a key solution for a carbon-neutral future. Especially, we are working together with the OECD NEA to accelerate innovation, improve safety, and promote global role of nuclear power as a key solution for carbon-neutral future. In line with this, we are making significant effort to adopt disruptive technologies such as AI, 3D printings, and high-fidelity simulations. Together with the NEA, we are right now planning to co-organize an AI workshop to explore how AI can empower and optimize nuclear installation while ensuring regulatory compatibility. At the same time, we are right now developing a virtual SMR platform. It is a kind of a digital environment that utilizes large-scale GPU simulations to accelerate new system design and to reduce development cost, and finally to improve overall efficiency. International collaboration is a key to accelerating and advancing nuclear technologies. Through collaboration, we can achieve more. And finally, we will deliver safe, affordable, and clean energy to everybody. I firmly believe that conferences like SCOPE are the very place where such cooperation begins. Before closing, I'd like to thank the SCOPE Organizing Committee for their kind understanding and for giving me this keynote opportunity, despite some last-minute changes in Cali delegation. Your flexibility and warm hospitality are truly appreciated. I truly hope that SCOPE will continue to grow and become a strong hub for nuclear technology cooperation in the Arabian regions. Thank you very much for your kind attention and warm welcome. I wish this conference great success and a fruitful discussion. Thank you. Shukrin.
Thank you, Dr. Ki-Young Choi. It is with a great honor that I introduce to you Dr. Ali Al-Sheikhi, the Vice President of Research and Innovation and the Chair of the SCOPE Steering Committee, for his opening speech.
بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين أما بعد. I'd like really to welcome you all here to SCOPE-2. But first of all, allow me to convey the greeting of the President of KFUPM, Dr. Mohammed Al-Saggaf, and his best wishes for a fruitful conference. Also, since usually I tend to forget, let me start by thanking everybody who contribute to this conference, all the technical committees, the College of Engineering, Dr. Khalid Al-Adl and his colleague as well there. Also special thank to the Center of Industry and Nuclear Energy and the director of the center, Dr. Afaq, and all of his colleagues and affiliates there in the center. Speakers as well who comes from all around the world, and I really to thank you for coming here. Our sponsors, KAKER, and also the presence of the Ministry of Energy as well here. I don't want also to forget KICS, our KFUPM Institute for Knowledge Exchange. I think they put tremendous effort, along with our event management company, Bro Events. Also thank him for putting all these great efforts to bring this conference into life. Just to remind you that KFUPM, with its transformation that started more than 5 years ago, we had just a simple objective, which is really to help in the diversification of the economy of Saudi Arabia by graduating the talent that will lead new sectors, Saudi Arabia. A number of sectors has been identified by the kingdom in general and also identified by KFUPM that we can contribute really in the diversification of the economy of Saudi Arabia. And one of them, I don't want to dwell into all of them, but one of them is energy in the general sense. It's not only oil and gas, but the cleaner energy, hydrogen, renewable, all of that. Of course, nuclear is going to play also a major role in that because it's hopefully that it will give us more sustainable, cleaner energy, and it's an important part of the energy mix that Saudi Arabia is really promoting. And also at the same time, we are helping in achieving the United Nations SDG goals, a number of them, but directly one is the provide affordable energy to people around the world. Our gathering here discusses many topics from nuclear reactor design and physics, thermal hydraulics and safety, nuclear material and fuel cycle, and application and radiation processing. The conference challenges us to lead not only the technology, but with wisdom and compassion, to use our discoveries to make the world safer, cleaner, and kinder. Let's use the conference to share knowledge, to inspire one another, and to ignite new partnerships that transcend boundaries. From the heart of Dhahran, we are sending a message to the world that the Kingdom of Saudi Arabia stands ready to lead the innovation that will power our planet's future. Together we will dream and we will accomplish, and together we will lead the innovation. And let me just go back a little bit about KFUPM, that here also we live by a simple but powerful belief, which is dream big and accomplish. It is not a slogan, it's really a promise that fueling our researcher, inspiring our student, and guiding every partnership we forge, so we can all contribute to the world's most pressing challenges. Today also KFUPM proudly stands among the top 67 universities in the world based on the latest QS ranking. Beyond the ranking, what truly defines us is our impact, our ability to transform ideas into solution and solution into progress. Through more than 20 interdisciplinary research centers, KFUPM is driving an innovation in energy, water, sustainability, material, and digital transformation, all anchored by one vision: to build a future where science serves humanity. Also, as you saw today, the unveiling of the SAMA project, which is, as you saw, Generation 4 Small Modular Reactor, SMR, design, and it was born from our collaboration with Paul Scherrer Institute in Switzerland. I'm really proud of these small steps, but I think steady, towards helping really the Kingdom Vision 2030 and even contributing in the overall arching goals of even the world in general. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
Thank you, Dr. Ali Sheikhi. Throughout their generous support, SCOPE is privileged to have the opportunity to collaborate with our sponsor, King Abdullah City for Atomic and Renewable Energy. And now join me in welcoming the representative of KCARE, Dr. Sharaf al-Sharif.
Ladies and gentlemen, in the line of the spirit of collaboration and innovation that define this conference, we are honored to witness the exchanging of memoranda of understanding between King Fahd University of Petroleum and Minerals and several distinguished international institutions. These agreements make an important step in strengthening global collaboration in nuclear education, research, and innovation.
And now we would like to invite the representatives of today's MOUs exchange on stage, which include firstly, Bolshoi Institute, Switzerland.
University of Pisa, Italy.
National Center for Nuclear Research, Poland.
University of Sheffield, United Kingdom.
European Nuclear Education Network.
Now it is the time to capture a historical moment with a group photo. Please stand and join us. And now we would like to invite our distinguished guest for a short tour around the exhibition area. Thank you for your listening.
1. بسم الله الرحمن الرحيم. 1 1 تشيك 1 تشيك. هلو. بسم الله. بسم الله الرحمن الرحيم. تشيك 1 تشيك. بسم الله الرحمن الرحيم. ايش؟ طيب خليه يفصل.
Ladies and gentlemen, it is my great privilege and honor to introduce Véronique Royer, Head of Nuclear Safety Technology and Regulation Division at the Nuclear Energy Agency. Since 2019, Véronique has led this division, driving international collaboration and shaping the future of nuclear safety worldwide. Her distinguished career spans more than 3 decades in nuclear safety and research. Before joining the NEA, Véronique served as Safety Research Director at the French Institute of Radio Protection and Nuclear Safety, where she managed extensive research programs across nearly 20 laboratories and fostered cooperation initiatives at the national and international level. She also covered the role of Deputy Director for Scientific Projects, Strategic Development, and Partnership in the same institution, IRSN, advancing strategic priorities and partnerships for nuclear safety research. Earlier in her career, Véronique coordinated criticality safety activities, focusing on nuclear fuel cycle facilities and safe transport of radioactive materials. Her commitment to education is equally notable. She lectured and led training workshops and was responsible for the Nuclear Engineering Master Program at the National Institute of Nuclear Science and Technology. Véronique holds a master's degree in chemical engineering from the Polytechnic Institute of Toulouse and a postgraduate master in nuclear engineering from the same National Institute of Nuclear Science and Technology. Her expertise and leadership continue to play a key role in strengthening nuclear safety framework globally. Today, she will present Safe Nuclear Energy for the Future, Bridging Fundamental and Innovation. Please join me in welcoming Véronique Royer, a leader, a mentor, and a trailblazer.
Thank you so much, Martina. It's too much for me. So it's really a real pleasure to be with all of you today. It's the first time for me in Saudi Arabia, and I'm very impressed by all the technical progress, and especially in the nuclear field. So thank you for the invitation. It's a great honor and pleasure to be with all of you, and especially to talk to the young generation. And I'm sure that you will provide a lot of new future technical experts soon. I would like to begin my remarks by reminding everyone that we are currently experiencing what could be called a turning point in the history of nuclear energy supply. We are facing major critical challenges of environmental protection, economic development, and energy security. And there is no silver bullet to solve this continuum. Our goal is to address these challenges with maintaining a high level of safety. And you know I'm from this area. So, and you could be, in the future, one of the key players in this area. For a long period, I have to test, no, this one, yes. For a long period of time, nuclear energy development and operation was the appanage of the governments. During the last 10 and 15 years, we observed a significant transfer towards the private sector. Nowadays, it became clear that governments and private sector must work together for achieving the massive goals in front of us. The NEA, until recently a relevant convening place for governments, is becoming, I believe, a relevant place where governments and private sector work together to find the right solutions, using the knowledge of more than 3,500 experts from the 34 member countries, but also other countries involved in some way in nuclear energy related topics. So I encourage you to check the variety of NEA publications, all free of charge, and you can find very technical reports as well as policy papers, common positions, recommendations on a large scope of topics. Global concerns are prompting nations to reassess their energy plans. Many countries are therefore trying to identify ways of speeding up the deployment of nuclear energy through advanced nuclear technologies. A few years ago, we could never have imagined of the number of facilities being built, planned, or proposed all over the world, and including here in Saudi Arabia. The reduction of regulatory and safety control costs and timescales, and the promotion of international cooperation, particularly on the subject of the regulatory context and constraints, are increasingly taken into account by decision makers. A changing nuclear landscape and infrastructure development has also a large impact on regulatory activities and regulators' challenges and priorities. The NEA Committee on Nuclear Regulatory Activities issued a statement reaffirming good regulatory practices and principles on July 24 in support of international efforts to meet the aspiration goal of tripling nuclear capacity by 2050, as stated in the declaration by more than 25 countries during and following COP28. And then the CNRA, this committee recognizing the growing nuclear capacity and capability, will require for all parties concerned significant increasing not only industrial capacity but also human capital in science, technology, engineering, and mathematics. Acknowledge also that developing and maintaining competent human resources is fundamental for the effective regulation of the nuclear industry. The statement also highlights a specific point related to innovation and another one about the essential need in terms of verification and validation, which is a permanent challenge for all related simulation tool topics. Any ambitions for nuclear education and workforce development in order to support the effort required different essential points. Leveraging benefits of our activities and in-house expertise into practical materials, seminars, and joint projects, and so on. Expanding importance of the hands-on training for students and young professionals. Enabling a long-term dialogue among academic institutions, policymakers, and key stakeholders of the nuclear sector, but also society worldwide. Continuing the dialogue with regulatory bodies to focus on specific needs raising from different analysis and surveys, and building the STEM pipeline by engaging also with secondary schools and students, of course, and teachers. And last point, increasing the proportion of women in the sector, support their education and career development. The most recent initiative we have in the pipeline is to launch a first session of the Safety Assessment of Nuclear Design Institute, named SOUND, with the support of one university to address needs from regulators, but also TSOs, vendors, students just post-PhD students, and other industry actors in preparing new staff, including these very rich material, that is to say students, on the market to be better prepared to safety assessment analysis. King Yong told us about artificial intelligence. Yes, we are close together, very sensitive to this topic. And concerning artificial intelligence, I consider that nuclear energy must not be left behind, for sure. We must keep in mind that human error contributes to around 80% of nuclear events in the industry. Nuclear energy has an opportunity to apply disruptive technology to lower costs, to build, operate plants, to improve quality, efficiency, to achieve higher levels of nuclear safety as well. AI applications are already being applied beneficially to information management and other similar tasks, but the true benefits of these technologies may be when they are applied in nuclear technology design, but also construction and operation at the same time in a coordinative manner. The nuclear sector must attract young scientists, which is a good point, and engineers. And they increasingly view nuclear energy with this new focus, not as an old industry, but as an advanced industry. Let me try to better focus on opportunities for AI to enhance nuclear safety. In fact, there are many potential benefits to nuclear facility processes, including enhanced nuclear safety, concerning operational support first, concerning maintenance support, how to anticipate this maintenance support, developing autonomous inspections, maintenance of different process, and organize this maintenance. AI is essential as well to the use of autonomous vehicles of different size to support movement of nuclear waste, spent fuel, and so on. It's more classical, I would say. Also, autonomous dedicated control command systems for safety-critical devices, including reactor remote operations, can be developed, but carefully. And also an important interest is in the use of autonomous systems to assist reactor and nuclear facilities new built and retrofit on existing facilities. And finally, risk-informed engineering and decision-making are largely more efficient depending on the quantity and quality of data available and how you pre-analyze these data to prepare your decision, your further decision. So we can consider that successful application of AI to the nuclear sector is essential to the future, to be used progressively, but with a long-term view. Because disruptive technologies like AI application can provide innovative solutions to long-standing challenges in the sector, including for the safety community. Regulators themselves do not want to be obstacles to this progress. They also have to take into account the specificities of these and the challenges of AI in their future views and future work. AI and other disruptive technologies must be proven to be consistent with the safety requirements of nuclear regulators. It seems obvious, but it's not easy. The private sector must work on identifying the benefits of AI in order to make the sizable investment necessary to support regulatory review. The expertise to understand and analyze the benefits and risks of these technologies is rare, especially in the nuclear sector. Less and less, I would say, and we have to progress on this, especially for regulatory bodies. And the last point, you know, all of you, is about cybersecurity. Cybersecurity is already an urgent and growing concern and may serve as a major barrier to adopting many digital technologies in the nuclear sector. But we need a trustworthy nuclear energy to also maintain public trust. Licensing is based on historical principles, well-known and widely recognized reliable throughout the world. It is important to remember that the main priority is to protect people and the environment at the same level of reliability while supporting the development of nuclear energy. This is to say that the philosophy of nuclear safety is not drastically changed, but must be applied to new and healthy ecosystems, innovative ecosystems. This philosophy is based on well-established scientific principles that undergird fundamental safety rules. Nuclear safety is primarily the licensee's responsibility, whatever the organization put in place, and especially the regulatory body. Constant technical dialogue enables shared understanding and quality. And these principles seems to be essential on the long term. Continuity and stability with an open mind towards modernization, flexibility of oversight, international collaboration, and control at the national level are the pillars of this philosophy. So we have now to see how to incorporate the issues raised by some new technologies like AI into these fundamental principles. So, for example, for AI, many questions remain, especially related to safety issues and reliability. I provide here a list of typical questions that we have. Of course, it's really a first points. I will not provide details about all of them. Will regulatory framework need to be changed? We can ask the question. Is validation with only limited verification acceptable for the community? This is a key question. And so on. Can the data be trusted? We have to characterize that and to have some criteria about that. Does industry-proven technology present higher risk than nuclear qualified technology? I'm not sure. How ISO standards has to change due to that, and so on. To shed light on the debate, I would like to draw a parallel with the OECD reflections on and work on the same topic in a more general way. The OECD identified the key principles for a trustworthy AI to protect people and the environment while supporting the adoption of trustworthy AI in society. The OECD identified a similar philosophy essential to the development of and the application of AI. And then they identified a series of values based on key principles, and also they proposed a general set of recommendations for policymakers on this topic. I will not develop that. You can find this on on the OECD website, but just let me highlight a few of these principles that we consider as common and interdependent principles and very consistent with what we would like to do for the nuclear sector. They talk about transparency and explainability, about robustness, security and safety, about accountability, and of course, international cooperation. So, trustworthy AI and safe nuclear energy are compatible, considering strict principles to be applied. AI and nuclear energy presents synergetic opportunities, consistent principles, and they focus altogether on the interest to build an adequate international collaboration to overcome technical and regulatory challenges. First, in terms of validation, of course, new validation approach and methodologies will be needed. Second, concerning regulation, regulatory adoption requires industry and regulatory resources, expertise, and identified benefit. With no benefit, there's no interest. And third, about the essential condition for bridging all players together. And this is one of the points we can work together. So now, just coming back on fundamentals again, let me recall the specificity of a regulatory context in our sector in terms of safety assessment and licensing. As you know, it includes all the needed steps to assess and to confirm that the 3 C's requirements, control, cool, contain, are all along the reactor life, are controlled all along the reactor life. And consider safe operation in normal conditions, but also anticipating operational occurrence, external, internal events, and potential accident is a first point. Evaluate studies of accident prediction, source terms, mitigation measures, evaluate the efficiency of multiple barriers. But the new context is that they are facing now more and more multiple designs, various reactor and components, systems, and also emergence of new technologies to be implemented in the reactor efficiently or safety applications with the reputation to be more reliable, more safe. So in any case, we have to check all this process with this new context. Check the safety assessment of the fuel behavior, material behavior, containment, up to emergency response, which is part of the evaluation. This picture shows the breadth of the portfolio related to licensees' responsibility first, and then regulators' responsibility to approve and assess this. And this is a large scope. A large scope of technical fields that need to be covered and that need to be investigated by experts and technical engineers. This is why I consider that an important condition for success and for confidence in these decision makers' ability to base the decisions on effective and efficient safety assessment is to be underpinned by a policy of research excellence. Maintaining and deploying nuclear energy must be based on confidence. Confidence in the knowledge of the risk, integrating a holistic view on both social and technical elements. And at the same time, a policy of research excellence is essential to build and maintain expertise as a tool for trust, following indisputable process and methodologies. We don't know everything, but we have confidence in the risk analysis that is made available to decision makers. The decisions should be informed by uncertainty analysis, sensitivity analysis, as efficient as possible. And then the research contributes concretely to building confidence in conservatism, in the safety margins proposed by licensees, and in the performance of the tools used to support the decision. This is all the more important when the decision is based, and it is more and more the case, on a best estimate assessment and on data directly and data analysis directly from monitoring or from AI analysis. At the same time, a policy of research excellence must be based on a rigorous and systemic, well-known approach based on key steps, typically listed on the left. These two components of safety policy must be closely linked to be effective. The connection is established through the databases and through simulation tools made available to all actors. Only a dialogue, a quality dialogue between them can ensure that they are in control of these elements, and for the long term, and that they know what is behind, what are the limitations. They can ensure that the problems are well formulated, which is not easy, and that possibilities to optimize the system can emerge. This global dialogue is also the only way to optimize the use of full-scale experiments, which are definitively essential for solving important problems. So just this slide to remind that the NEA is a unique place where experts can collaborate in this sense on key safety assessment topics, coordinating activities with other organizations. This is where technical results and data are shared and discussed. Key topics include safety of components, structural system, risk assessment approach, and accident analysis, fuel cycle, data management, and also, more recently, a special focus on specific R&D needs for SMRs. On the right, you have a more detailed list of current activities. I will not, of course, comment this list. So we were there. We developed during 60 years a series of experimental joint projects, mainly focused on light water reactors. And these projects were covering, on a very long-term perspective, hot topics related to what I explained before, including fire events, for example, and propagation, severe accident, long-term operation, and so on. And now, regarding specific issues on specific new designs, the NEA also tried to develop an approach to address the specific challenges facing by SMRs in a coordinated manner. That is, that the first different steps were developed. First, the NEA follows SMR readiness through a specific document named the dashboard, and investigate technical gaps and resource needs in several working group activities. We published in 2023 a technical opinion report to summarize research recommendations to support the safe deployment of SMRs. And one of the key points you can imagine discussed in this report is related to the need to engage V&V activities and to initiate new efforts or promote and collect new data. So I will go then directly to where we are today. So we try to develop a new nuclear safety research roadmap to take into account the fact that we have to investigate perhaps new areas. And in this roadmap, we try to provide a series of high-level recommendations and also recommendations for actions for different stakeholders. And these documents have been published, so I can show you the link somewhere on the slide. And these documents are for us like a guidance to go from the, I would say, the old world on safety research to the new world. But what is important is to maintain the continuity and to preserve the data and the knowledge. And then what we would like to do with this roadmap is also to develop new frameworks, to develop new experimental facilities based on, and maintain these facilities in the best position to, in a coordinative manner, to develop their common programs with their own specificities. So it is the more advanced platform that we would like to put in place in this way is named Athena, is focused on thermohydraulic experiment for nuclear analysis and safety framework. And we are currently in the final phase to establish this platform, and I hope that it will be very helpful for future development. So, to conclude, I would say once again that a policy of excellence in research is essential to support informed decisions that inspire confidence and trust. To achieve excellence, regulators, but also all the actors, academic actors and so on, must continue, of course, to learn from the past to prepare the future. They should never consider a priori that a problem doesn't exist or is not severe enough to merit action. The most important thing is to find what was missing and create something new that was missing, even if, to do so, one must venture into a completely new field or area of weakness. Determining priorities is of very great importance, but it's very difficult. We must also expand the research issues largely among the scientific community, perhaps more than it was in the past. In general, as a newcomer, if I put myself in this spirit, I would consider that the main points I have to investigate is how to empower through knowledge management. Then I have to take the opportunity of these new technologies to connect the generation all together. If I would like to talk about safety, of course, knowledge is essential to safety. It's not only to know how it is, it's to know why it is like this and what I don't know. And of course, the last point is about collaboration. And we are here to investigate all these points, and I thank you again for the opportunity to discuss with all of you these points. Thank you. Oui, mais où?
Ladies and gentlemen, it is my great pleasure to introduce a distinguished leader in the field of nuclear science and engineering, Leon Cizeli. Leon is currently the director of the Joseph Stefan Institute in Ljubljana, Slovenia, the national leading scientific research institute. With a staff of about 1,300, the institute covers a broad spectrum of basic and applied research in natural science, life science, and engineering. Leon's academic accomplishment reflect his dedication to advancing knowledge and shaping the future of nuclear science. He is a full professor of nuclear engineering at the University of Ljubljana and also serves as visiting professor at Harbin Engineering University in China. Leon has held prominent leadership roles, including president of European Nuclear Education Network and president of the European Nuclear Society. Leon's influence extends into academic publishing as well. As editor-in-chief of the Journal of Nuclear Engineering and Radiation Science, and serves also of the boards of both nuclear engineering and design and science and technology of nuclear installations. He earned his PhD in physics from the University of Ljubljana in 1993 long time ago, and has since authored or co-authored more than 1,000 publications. His expertise is widely recognized, with over 200 interventions in Slovenian and international media. Today, he will moderate the panel discussion, lead the innovation. Please join me in welcome Leon Cizeli, an innovative leader, an expert, and a passionate advocate of scientific process.
Martina, for this very kind introduction. I already feel very important. That's very probably good. But let me now invite my distinguished panelists to join me here. So you already know Mrs. Veronique Royen. Thank you very much, Veronique, for a very nice introduction and very nice overview of what might be important in nuclear education and nuclear innovation. And then the next one is distinguished panelist is Professor Andreas Pautz. And Professor Emilio Balieto and Dr. Hanok Kang. And I have to apologize for Dr. Mohamed Garwan. He had a last-minute restraint in his mission in abroad, so he cannot join us today, which is a pity because he's a real knowledge. He has a real knowledge of the Saudi ecosystem. But anyhow, let me introduce my panelists now. So Andreas Pautz. Andreas studied physics in Germany, in Hanover, and then in Manchester, in the United Kingdom, and earned his doctorate in nuclear engineering at the Technical University of Munich. Then he joined Northern German Nuclear Authority, TÜV Nord, Framatome, and finally the Gesellschaft für Reaktorsicherheit, German TSO, before becoming a professor, a nuclear professor at Polytechnique Lausanne in Switzerland. And he's in a combined position with Paul Scherrer Institute today, where he is leading the Center for Nuclear Technologies and Scientists and is member of the PSI Board of Directors.
Thank you.
Emilio Balieto. And he is today the Tokyo Electric Power Company professor and associate head of the Nuclear Science and Engineering Department at Massachusetts Institute of Technology. His bachelor's and master's are from Pisa University. He has very few fellow Pisa University people also here today. PhD from Tokyo Institute of Technology. And he then did spend some time in nuclear industry before becoming the professor. And if you would be curious what he is doing, what is his research focus, look at his T-shirt. It's turbulence. So welcome, Emilio.
Thank you very much.
And Dr. Hanok Kang, a principal researcher at the Korean Atomic Energy Research Institute, specializing in design of advanced light water small modular reactors, with the PhD from Seoul National University in 1996. So I'm not so alone here.
Good. Nice to meet you.
He's now actually he served as project management director for the Korea Saudi Smart Pre-Project Engineering and recently supervised the Smart 100 design approval and innovative SMR technology project. So we have also an SMR, small and modular reactor, or smartly marketed reactor guy. I like the acronym one way or the other way. So please join me in welcoming my distinguished panelists again. Thank you very much. Now let me start the talk about innovation and research. Now innovation in nuclear, in very successful industries like nuclear industry might be sometimes interesting and tough cookie. So You know, I like some oxymorons, and one of the nuclear oxymorons, which we make many times, we say this in public, is we do trust in proven technologies, and we are here all for innovation. This cannot go at the same time, but so we do have some innovation, sometimes it's hidden a little bit. Well, now, starting with Andreas, as you are working in Switzerland, which is now, I guess, for about 10 years or more in slow phase out of nuclear power, slow meaning they just wait for the nuclear power plants to expire indefinitely. But then at the same time, you have pretty strong discussions about revival of nuclear. How would you see the role of the innovation and research in nuclear in this, let's say, very, very interesting combined position, phase out and going for a new build?
Thank you for this question. It is a tough question. So, first of all, I mean, Switzerland ranks consistently amongst the most innovative countries of the world. If you look up any indices for that, Switzerland ranks high. So, of course, we also want to pride ourselves for being innovative in nuclear. Now, as you mentioned, we have, technically speaking, a phase-out decision, meaning that we only operate our existing power plants, and hence innovation will not be disruptive. Nevertheless, there is evolutionary steps also in topics that we still need to serve for the next decades, right? I mean, we are talking about plant operation well into the 40s, likely into the 50s or 60s, because we will clearly go for long-term operation. We have, like all countries operating nuclear, of course, to deal with the radioactive waste. That's a major topic, and that is very interesting in terms of innovation. And of course, as a research institute, we also have the responsibility, I feel, that we drive innovation if nobody else does it. Because, as you also mentioned, there might be a public decision to go for nuclear again. I mean, I cannot look into the future, I have no crystal ball, but yet I see it realistically that the Swiss population will vote in favor of nuclear in maybe just a couple of years, and then the situation will drastically change. But I give you maybe a couple of examples where I see this evolutionary innovation happening. Long-term operation. I mean, we will all deal with long-term operation, and Switzerland prides itself for having the oldest operating power plant. Some say also the most mature power plant. That's in the perspective of the viewer, of course. And so, therefore, we are spearheading the long-term operation experience. There are topics enough: corrosion control, materials aging, predictive maintenance. I mean, Veronique pointed that out very nicely in her talk, that also go along with long-term operation. The other example is radioactive waste management. We have a very advanced plan for our deep geological disposal, almost as advanced as the Scandinavian countries. And you know, reactor engineers like to think of a radioactive waste disposal as a big hole in the ground. I can tell you it is a bit more. It's a highly complex multi-physics, multi-scale system, geochemical, thermal, hydraulic, I'm forgetting one, mechanical, coupled system. And the optimization of this is a highly, highly complex task. And I would not underestimate this. So, and the interesting thing is that my colleagues from our laboratory for waste management have discovered this topic, the topic AI, for themselves for these optimization tasks. And interesting enough, the laboratory for waste management has become the main driver for AI applications at PSI. So there is innovation happening for such tasks. And now, of course, I mean, last but not least, for this time, you have seen our nice reactor design outside. Dr. Afaq already showed it at the beginning. So I invite you to come to our booth and take a look what we can achieve together with our, well, wonderful collaboration, great minds and great students here especially. So, I mean, that's innovation too, that we want to take research being taken to the next step.
So thank you. You are all invited then to the Sama reactor.
Yeah.
I guess Afak said Sama means sky in Arabic. In Slovenian it means a woman being alone. So maybe you also collect some different languages. Maybe you can get a good slogan for smartly marketed reactor also out of it. I propose that we go one round of questions from my side, and then I will open it to the public. Also, the questions for Veronique could then come in the public round. Now to Emilio, you are now in United States. You were partly in the industry before becoming a professor, which is probably a very good idea. So you can connect a little bit the innovation in the industry and in the academia, which could be pretty different ecosystems, I would say. But let me go from this angle. The United States was the cradle of nuclear technology in the first round in the 50s. Not really the first commercial nuclear power plant was in US, but it was in United Kingdom, but okay. Then you dominated. Now today also the density of SMR startups in the Northern American continent would be the largest in my perception. So how do you see that this startup business connected with the strong innovation capabilities?
Very good question. Let me try to give you an answer that is not too critical, right? Which sometimes I'm accused of. First of all, looking at the data, absolutely, right? The amount of innovation that we're seeing in the nuclear industry is incredible. I haven't counted recently, I lost count, but last time we counted, we had over 70 fission new startups in the United States. And now we have, I believe, something in the order of 40 fusion startups. So we have 100 companies that tell you that they will be able to put some new magic power on the grid by 2035. Okay, so there is a lot of claims out there. If I look at the positive, I see a very good, I think you mentioned the word ecosystem, right? So I see a very good ecosystem in the United States that has driven this kind of innovation. To get to that, I think one thing that the United States does very well is to split the roles, have very minimal overlap, and very minimal competition. And so there is the academia, there is the research laboratories, there is the industry, and there is the regulator. And I think how we are able to work that ecosystem together is a very good example, right? The projects are always driven by at least 3 of these 4 elements, right? We try to not overlap all 4, but there is always a strong participation from 3 of them. And I think what made the big jump, of course, is that we are in a competitive market. That is, nuclear will never be pushed in the United States by the government. And so I think what gave the big kick was when the industry, so when the market realized that nuclear power was, again, something they really wanted to access. But the classic vendors and the offering that we had was not very different from what you were mentioning, so what we designed in the 60s and 70s. So there was a strong need for innovation. So that was the big kicker. But then the way I think that it was achieved, this starts, of course I see now strongly the view of academia, is how we push the innovation is through the culture, starting from how we select the students, how we try to train them, empowering them from the very beginning, right? I think at MIT, for example, we have a great thing that our funders, both in the way we value our faculty, our students, but in the way also all the research projects are assigned in the United States, I would say we don't fund papers, right? We fund impact. We use the term impact at MIT very strongly. And impact can be anything, right? Can be very fundamental research, can be very applied research. It has to be something that makes the difference. And when we work with the funding agency, that's what they recognize. The energy group of the ARPA branch is an excellent example, right? I love working with them because my quarterly reports are not 100 pages documents, are 5 pages telling them how am I achieving what we're trying to achieve, And I have a team of 10 people on the other side that are asking me, how can we help you achieve it? Not, have you done enough? Okay, and so that's the strong part. The students see this. They come in, they see the opportunity to have their ideas applied very fast. And these young companies, allow them to really see the application immediate. And so that's why they are attracting so much talent. And so I think there are a lot of good news. Maybe to close on one thing that concerns me a little bit is that I grew up, I decided to be a nuclear engineer probably a year after Chernobyl happened. I joined MIT a few months after Fukushima happened. And so I was always the ugly duckling, right? Nobody liked nuclear. And so who stayed in nuclear was somebody that was extremely motivated. Now suddenly everybody loves nuclear, right? And I see greed coming into nuclear, and that's something that I'm concerned of, right? Over-promising, not being realistic with what you can achieve, and that can stifle and can create trouble. So the greed is something I would hope to keep out of our industry.
I'm not really willing to comment that one, but I hear you. Well, perhaps a good line or starting point for Dr. Hanok Kang. You're coming from Korea, and Korea is today one of a very few countries who are actually capable of producing a gigawatt scale reactor, or what some people also call big boring reactor, those which make money and electricity. So, but you are at the same time also very strong in the development of innovative small modular reactors. Also recently, Korea was in the political turmoil. One of the presidents was against nuclear power, and I understand that the nuclear academia, the professors and the researchers were instrumental in helping the public debate going again in the nuclear future. So at the moment, I think you are as a country turned into the nuclear future. How would you see the innovation ecosystem helping and managing all that? So producing the big reactors, developing small reactors, steering or helping the politicians to decide in the interesting directions.
Negative thing of that your question is that first the answer is that yes, government changed this year, and now government is trying to reorganize some government structure for the nuclear energy. Also considering some long-term electricity supply plan. That's just little bit some negative, but some positive aspect is that this is not first time. So maybe I think you can handle this kind of situation now. But before directly dive into your question, I talk about what is SMR, what purpose of the SMR. Yesterday I participated in a workshop in here. I really enjoyed some civil accident and some hydraulics, and I was in charge of that SMART and ISMR project for the right order reactor SMR. And I talked with some nuclear society in this subject of SMR. Many colleagues asked me that SMR can substitute that large nuclear power plant in Korea. So my answer is no. So mainly, I don't think that SMR can substitute large nuclear power plant because I think that SMR can create more different and some expansion of some nuclear energy field. It can have more flexible load powering capacity, and compared to the large nuclear power plant, it only for the base load in Korea. In this the renewable energy dominating energy system, SMR can be more adequate for that purpose. Also, it can supply for the other thermal energy field like desalination, hydrogen generation, or thermal energy for some industry field. That's my answer. So As you mentioned, that Korea is one of the few countries can design, operating, and some operation and construction for the large nuclear power plant, also leading some small modular reactor development. And recent year had some dispute about the role of nuclear energy in nation's future. In this discussion, academia and industry, some institutes like KERI and industry work together, convey some clear and evidence-based message to the government. When you think about the carbon neutrality, it's a main issue recently globally. It's not just increasing of renewable energy. If only increasing renewable energy, it is not just the answer. We need consider how can we harmonize the renewable energy with other carbon-free energy source like the nuclear or other can be used. Korea is peninsula, as you know that. But in viewpoint of electrical grid system, it is something like some island because that we are connected to China, but between them we have some North Korea, so we cannot operate grid system like Europe. Europe is can work with some other countries, some exchange the electricity, but you cannot do that. So currently, in last year, I found the number. The coal and the LNG is about 57%, 60% that is portion, and nuclear is about 30%, and renewable is about 10%. Now, to achieve the carbon neutrality, we need to try to increase the renewable, maybe some 50%. Then it cannot be just a solution because you cannot predict the renewable due to the intermittency, due to solar and wind. Also, we need to increase increase of the transmission line. So we need to consider how can harmonize the renewable and nuclear. And recently, in the national survey, 87% of the Koreans response that nuclear is necessary, and 75% of respondents think that nuclear energy is safe, and 65% of young age in their 20s is supported some expansion of nuclear energy in some Korean energy mixture. At the center of this renewed confidence, I think lies the development of SMR. SMR is just some paradigm shift, as Veronica had said, paradigm shift toward the new generation of the nuclear energy. SMR also is evolving multi-purpose energy platform capable of some electricity, hydrogen, and desalination water, and industrial heat. In June last year, government announced the next generation nuclear development strategy, and which including $1.8 billion with huge amount of the money scheduled for the next generation nuclear development. Also, government declared some support for we call public-private partnership to accelerate the SMR commercialization. Actually, SK and Hyundai, Samsung, or some POSCO, big company in Korea, actively engaged in this kind of PPP, some partnership. So in conclusion, I think that SMR can have some very crucial role in the shaping the both energy policy and public acceptance in Korea. Thank you.
Thank you very much. And now last but not least, Veronique, let's go to you. A short question for you too. Now, the Nuclear Energy Agency of OECD has a very strong focus on nuclear science and also safety. How do you see that where the main future efforts will be needed in innovation to somehow embrace all the new technologies and regulation for new technologies coming on the market? Is this, would perhaps harmonization, international harmonization of the rules, or well, the basic principles are harmonized very well, I guess, but the rules, can we go there? Can innovation help? Can research help? Or is this...
I'm not sure, but no. So at DNA we have different type of views. First, I very quickly explain that we produced, thanks to our members, a document to anticipate nuclear safety research in the future, and just to involve everyone in this discussion. This is the roadmap, the documents are available, and then the second point is to alert and to get more sensitivity on the need to maintain facilities, experimental facilities. With that, you have experts all over the world. This community is really ready to collaborate. So you can easily, with a strategy and with facilities, you can build a community of researchers, and they can go very fast to progress. So I think it's really essential, first, to alert our decision makers on this need to maintain this capability, first. Then about safety, harmonization, and so on. The data are harmonized. The tools are close to harmonization in some way. The methodologies and so on can be made available. The data, sometimes it depends. For fuel topics or things like that, it's more difficult. But anyway, because you have the competition in any case. About the licensing process, you already have a lot of high-level initiative on this. I would say on my side that I don't like the word harmonization. I prefer to use convergence. And on the technical issues, you can get a convergence. But the licensing process is something different. The context of each country can be very different. And it's different in principle, but also in detail. So what we had in the past several initiatives. I can mention the MDEP initiative, Multilateral Design Evaluation Project. It was a period in the 2000s where there were a very strong competition between the developers of Generation 3 reactors. But altogether, the regulators were in front of these new reactors, and they said, wow, we have to collaborate to evaluate if we can have on some topics common positions. And with that, even if it was not a perfect success, because the status of these reactors, of the development of these reactors were so different at one time. So it's difficult to have the same level of detail and so on. But so they could provide some common positions. So now, if we have a set of 3 or 4 countries who really would like to develop in the same way a new innovative design or to license a design, they can work together and try to develop common positions on the way they will analyze the topics. And then they can have a common licensing or not, depending on the rest of the context. Typically, for example, the site evaluation. In some countries, you have to do that before the licensing. In other countries, you have to do that, or you can do that after. So the licensing process is different. So I think we have a lot of roads in front of us to progress, to converge. Harmonization, I would say, it's more difficult.
Thank you very much. I learned a new word today. but I would also put it together so we should converge in a new model of balance between cooperation and competition.
Exactly.
Somehow, but we need some competition at the end of the day. So thank you very much for the first round. I would like now to open the debate to the auditorium. Do we have any questions? And please, if you have a question for a specific panelist, tell us that. So, Katya, do we have a mic for her?
In the meanwhile, let me say that I greatly agree with Veronique's answer.
What?
I strongly agree with that.
Yeah. I see the panelists are a little bit divided around harmonization and converging, right?
Convergence.
Yeah, convergence, yeah. My name is Katya Slavcheva, and I'm the technical lead for the advanced water-cooled reactors at IEA, and it is my pleasure to be here. We have a paper on simulators for education and training, but it's not that for what I took the mic. I have two questions. My first question is to Veronique. You have mentioned in your slides that continuity is fundamental when we talk about AI as well. And we know, even without being so much experts in the AI, that AI needs good data.
Yes.
And as a lead of water-cooled reactor, I'm so happy that we have 60 years of operation of water-cooled reactors. How, my question to you is, how we can use this operational experience in order to give what AI needs, good data?
I'm not an operator, but in the past, on specific topics, I tried to investigate how to use some operation data for safety topics. And I realized that sometimes it's very difficult because the instrumentation in a plant, for example, the objective of this instrumentation is not to provide data for this purpose. It's really focused on the best operation of the nuclear power plant. When you use specific research reactors, you have specific instrumentation in these reactors to get the right data that afterward you can use. So there is a point here. You can use operating data if you implement in these reactors the dedicated instrumentation. So you have to think about that from the beginning. It's possible, but I'm not sure that right now all the data that you get from these plants are quality in the sense of safety, that is to say, you can use them to qualify different things and so on. You have also, you know that you have a lot of uncertainties. And when you perform experimental activities in a dedicated facility, research facility, the main topic is to manage the uncertainties. When you operate a reactor, the main purpose is not this one. You know? You have compensation, and you manage that because you operate the reactor. It's very general what I would say here, but I think that if you really would like to use these data, you have to implement and think how to implement the right instrumentation in these reactors. It's my feeling.
Thank you, Veronique. I agree strongly with you that research has a foundational place in the building of quality data that could be used tomorrow or even from today for AI. And I agree that it should be from the beginning. Prior I joined IEA, I worked in the licensing and regulatory affairs at Baraka Nuclear Power Plant, just here behind the corner in the UAE. And what we adopted in the Baraka project is safe management of data since day one, because this is extremely important, as well as cooperation with Republic of Korea, who is the vendor of this technology to the UAE. But enough about UAE. Now I have a question to you, Leon. I know that you are not a panelist, but you cannot escape from my question. As Emilio said, now we are on the wave of this favorable time of nuclear renaissance. It was not like this after Chernobyl, neither after Fukushima, when we grew up like engineers. My question to you is, what are you gonna say to these young engineers, ladies and gentlemen of Saudi Arabia here in the hall? What should be their main driver to stay in the nuclear indifferently if there is favorable time or there is not? Thank you.
Thank you. It's quite a challenge. Thank you, Katja, for this question. I am tempting to say, please give me the next one, but I'll try to answer a little bit. So Emilio nicely said that he joined the crowd in about, just after Fukushima. I joined the crowd just after Chernobyl. So in my experience, the number of students actually started to increase even after accidents. And to any time when there was, let's say, one or negative or positive debate on nuclear power, at least for my country and for parts of the Europe, that helps. So when nuclear has some visibility, and that's advantage of SMRs, that they increase the visibility of nuclear power. Another one is now, one nuclear reactor is with us for about a century. So consider 10 years of preparation, 60 plus 80 years of operation, and a little bit of dismantling. So the machine will be there for a century, and there is, so it's a long-term job, it's not a short-term job. And also the changes which are coming in a century are huge in the society. Now, let me remind you that the human-controlled nuclear fission is not yet 1 century old. It's about 82 years since Chicago Pile, I think 84 years, I guess. 42 was it? 42, yeah. So here we are, and then another that's the technical part of the century, the social part of the century. My city of Ljubljana was between 1900 and 2000 in 100 years in 10 different countries. The city didn't move, but that the social change which comes into a century. So you young people who are joining the nuclear, you will have a lot of space for work and for development and for innovation. Just help us sustaining this nuclear. Another question, yeah. Please.
Yeah, Luis Herran from the National Research Center for Energy, Technology and Environment in Spain. When I saw the title of the session, Lead Innovation, I felt like half of the title is missing there. And I would like to end up the sentence by lead innovation from preservation. And the reason why I am saying so, besides that I am getting closer to my retirement age, is that what I learned in the last decades is that, in many cases, and you all are aware of, those that we call advanced reactors are heavily based on something that we thought and we did experiments on in the 50s and in the 60s. But when some of us try to get to those data, they are not reachable, at least not easily reachable. So is the data preservation that, in my opinion, is fundamental also for these new reactors coming. And then there is a human aspect here. There is the expertise preservation. Those people who are coming to their 50s and 60s with that expertise never written in articles or never talked about in conference. The question is, are there any initiative to preserve or to share all that experience from NEA, from International Atomic Energy Agency, from anywhere else? Because this is also important, and some key expertise is getting lost in last years.
Any volunteers?
I'm not NEA and I'm not IAEA, so I cannot answer that part.
I can say something about that.
I can just explain that, you know, with that one of the role of the data bank at the NEA is really to preserve as much as possible these data. So, for example, okay, we have databases on different topics. We have also a lot of projects developed from the 16th up to now, and a large number of these projects, after a cooling time, I would say, of few years, depending on the topic, provided to the data bank all the reports and data available and developed during the projects. Recently, we made available for all the NEA members all the data produced by the ALDEN project on fuel, which is a huge amount of data. So we tried to do our best. We launched a specific group on this question, data preservation. But unfortunately, there are so many that have been disseminated and so on. We have very few areas where these data have been really preserved in the best way. And one of the topics where the data have been preserved is critical safety. And I know very well this topic. Because, why? Because one guy, one time, had exactly the same point as you pointed about all these very old experiments that have been developed in the 16th, 17th, all over the world on criticality safety, and decided to fund this project with the support of all the countries. And now we have a handbook where all experiments are in the same format, description, and with the most detailed way that we could have to describe the experiments and describe the data. This is an example where the job has been done. But there are a lot of our technical areas where it's much more difficult. So we are really, it's one of our expectation that also whatever the competition, whatever that people will realize how it is important to do that for a majority of topics, to save these data and because it's so costly, it's so costly. And also about operating experience. The IEA is doing a lot of job with us on operating experience, and it's essential. Perhaps not now, but in the future. So we have to continue to work on this, and it's costly. The problem is that it's a cost.
Andreas?
Yeah, maybe Louis, I think I can probably also support Veronique in this. I think the activity of preserving, for example, the Halden data was a huge effort, and I think a very much needed effort. So I think the NEA has done a wonderful job in trying to preserve and to maintain and to reprocess data that we had from old experiments. But you had another point, and I don't work at the NEA, but I happen to be the chairman of that activity, so I have a bit of background. The NEA called a few years ago for an activity, NEST, Nuclear Education, Science and Technology, and that was specifically meant exactly to what you have addressed, right? To mobilize this tacit knowledge that exists in the senior scientists, senior operators' heads, but that is nowhere being written down, right? So that's knowledge that is important. They know why you are doing something like this. And we really try to bring together senior scientists with young, aspiring people that would then go and travel to facilities, being host at facilities for so many months. And I think that was an important activity. Too small, just the beginning. But I think it was a very valuable experience for the young people because they really got the chance to work hand in hand with really experienced scientists. It's ongoing. I'm not the chairman anymore, but it's being continued. And I also would invite countries here from the Peninsula, Emirates, Saudi Arabia, to really join this activity because there's a lot to learn. And I think this is one of these activities that needs to be enhanced and expanded, where I think, but it was very valuable from the NEA side.
So since you had two people answering to Luis in the positive way of how to support him, maybe I can try a different angle since I consider Luis a friend, which is, I'm a big proponent of, yes, great that we are trying to save the data, leverage it, but I push very hard for generate new data. Because the people that generated the data had the knowledge of how you created it. Exactly. It's so important to generate, to create a new generation of young engineers that collects this data, generate new facilities to collect the data. We have been too often limited, even a lot of these companies that are calling themselves innovative, right? They're going to design a reactor that is from here to here because that's where the data was available, right? And they're not going to go out of there, right? My fuel rod is going to be HT9 because that's what we used in EBR2, right? And instead collect new data, make sure that we build this facility, that the engineers learn how to do it, and let's go for new stuff, right?
So I think we should slowly close. I'm sorry, no more questions. We should close this one. Let me just say one more sentence in the end before thanking my panelists. So innovation is people, and knowledge is better in the heads and the hands. But it's good in the books, but it's better in heads and the hands. So that's probably the message we would like to make here. Thank you very much for a very nice discussion, and thank you also to the audience for your very nice questions. Thank you.
Yes, microphone is working. Please, ladies and gentlemen, please do not leave the room yet and stay for this award session. So let me call the first award is for Dr. Hanon Kang from Kairi. The next award is from Emilio Baietto from Massachusetts Institute of Technology. The next award is for Véronique Royer, Head of the Division of Nuclear Safety Technology and Regulation from the NEA. Next one is for Andreas Pautz from PSI. And last but not least, I hope you have also an award for the moderator of this panel, Leon Cizeli, from the Josef Stefan Institute in Slovenia. Thank you very much for all of you to join in this session, and now it's time for lunch.